Okay, good afternoon, everyone. This one is our first session for a triple integration. So already we finished this double integration. So you will observe there is no change in the concept of evaluation of the triple integration. If you are able to integrate double integration, then triple integration will be a very simple for you. Right now, I written the type 1 of the triple integration. We have only two types here. So in type 1, the limits of triple integral are given. And just we have to integrate it. Just we have to integrate that. So right now the question is integrate, triple integrate of x cube y square z and the order that we are given as a dz, dy, dx. So right now the order is given, integration is given. Only the thing is now when we have to integrate the innermost integral first, say innermost is with respect to z there, we have to assume the other variables x and y as a constant. That is a simple concept. So if we start to integrate this triple integration, we will get I is equal to, yes, I think 149 you finished. So tell me what is the integration?
Yes, sir.
Yes, tell me.
Y square will be constant.
X cube into y square is a constant.
Z
So z square by 2.
to
Limit of z is a 0 to y.
1.
Dy dx. Okay, so that about the step number 1. Just we integrated with respect to z, assuming the others as a constant, they kept as it is. So this 0 to a as it is, 0 to x as it is. The limits of z we are given as a 0 to y. So when you replace upper limit, it becomes y square by 2. Y square by 2 into y square become y raised to 4 by 2. That's one. And lower limit, that's 0. So this one is after replacing upper and lower limit there. Any doubt? Now this question is not new. This is already we done in the last part. This is a double integration dy dx. The order is also there fixed. So because limits are in terms of x, so this is a dy dx only, that should be, and that is given that way only. So if we integrate now with respect to y, the integration, this x cube will be as it is. Integration of y raised to 4 is y raised to 5 upon 10 now, because that is 5 into 2. Limits are 0 to x and we left only dx. So that about the integration with y, assuming x as a constant. And the last step or last integration now we left as a this x raised to 5 and x raised to 3, the x raised to 8 by 10 dx. And now integrating with respect to x, this will come as x raised to 9 upon 9. The limits are 0 to a. Sorry, not 9, 90. This is a raised to 9 by 90 is the answer. So if you have doubt, any question, yes, you can ask. Is there any doubt? Okay, no
Sir,
doubt. Yes.
hello. Sir, in the first integration, we can keep the z also constant and we can integrate x now because there is only y,
So
0 to y.
yes, correct. So good observation. When the limits are in terms of a single variable like 0 to y, there are two possibilities. Yes, that limit can be of z or that can be of x also. But in such a case, whatever the order we are given, that you have to follow. Okay. So whenever the limits are given in a single variable, okay, like 0 to y is given. Now it is in single variable, so 0 to y limit can be of x, can be of z. In such a case, remember, you should follow the order as it is. Otherwise, you will get a wrong answer then. Okay.
Okay, sir, got it.
Got it. Okay, good question actually. So this is the thing that you have to observe, because here there is no ambiguity, because when you left this double integral, you'll observe limits are 0 to x, and that should be of y only. There is no ambiguity, but here is a problem. There is a problem that 0 to y can be of z or can be of x also, but because of that, whatever the order is given, that only we followed. That's all. So I'll show you the next question then. The example 2 is on the screen here. Evaluate the triple integral 1 to e, 1 to log y, 1 to e raised to x, log z, dz, dx, dy. Again, you will observe the limits are in x. Limit are in x. It can be of y or it can be of z. So again, there is a ambiguity. So because of that, whatever the order given, we have to follow it. Okay. So keep the same order. So because 1 to e raised to x is the can be the limit of z. So it is given the correct order, and so we have to follow it. So let me start here. So the integral I we are given as 1 to e, 1 to log y. Now we have to integrate the inner one with respect to z, assuming x and y as a constant. So let I ask 165, 165.
Hello. Yes, sir.
Integrate. What is the integration of log z dz?
So we will use isolate.
Yes, correct. But you can directly remember as a formula also. Integration of log z
Sir,
is
x log x minus x.
actually it is in z. So it is z.
Sir, yes, sir. So z log z minus z.
Correct. Okay. So directly this is a formula we can use. Otherwise you can use a by parts Eilert rule.
By parts, yes.
Okay.
So can I mute myself?
Yes. So that about the integration. That about the integration. Now triple one.
Yes, sir.
Replace this upper and lower limit and tell me what will remain.
Okay, sir.
Yes.
Sir, first term will be x e to power x
Okay, good.
minus e to power x
Okay.
and minus of
Huh?
under bracket
Huh? Yes, tell me.
sir
Huh.
minus of under bracket
Okay, tell me.
0 minus of 1. Yes, sir.
Okay, good, correct. So the two things that we used here, actually log of e raised to x. One of the formula that we use as log of e raised to x is x only. Okay, because log and exponential, these are inverse function, and you get log of e raised to x is x only. Another thing that we use as a log of 1 is a 0. Log 1. Actually, all these are logarithm at the base e. Even though we write log, log, actually they are ln, natural log. So they are the base e. So log of 1 is a 0 there. So we get here this value. This is the expression we left. Yes, we can integrate it directly without simplification also. Yes, 130, 130.
Yes, sir.
How to integrate this first term?
So we can do it by parts.
By parts. Very good. So by Eilert rule, this one is the u and v. So the integration will become, this is 1 to e as it is. Now we are integrating. So tell me the by parts of x e raised to x. 101, 140. I'm not getting the voice of anyone. Hello.
Sir?
Yes.
Yes, sir.
Hmm.
Sir, it will be x e की power ex
Correct.
minus ex
X
minus ex
e
plus
raised to
x.
x minus e raised to x. That's the integration of this first part. Okay.
Yes, sir. For the
Then the
first
remaining
part.
terms will be minus e raised to x
Plus x.
plus x dx dy.
Limit
Remaining
log
will
y.
be as it
Sir,
is.
sir, there is a question.
Yes.
Log.
This first step, x e to the power x minus e to the power x you did. This is by doing u integration of v dx minus integration of du by dx.
Correct. It is by
Integration.
parts, no? UV I
Yes.
written there. First into integration of second minus derivative of a first into integration of second. So directly written by parts. You can do it
सर
on
dx नहीं लिखेंगे ना
Sir,
because we have
sir,
already
dy,
integrated in terms of dx.
not a
pardon.
dx, dy.
So
Only
only
dy.
Should
given.
be only dy ना.
Yes, only dy there.
Sir,
Correct,
only
correct.
dy.
Very good. So this will be only dy there because already we integrated that with x there. The limit of x that we have as 1 to log y. 1 to log y. Now let me replace the limit. So 150, 150, 153, no answer. Okay, who is interested? Raise the hand.
Sir,
Yes.
the log y.
Okay. So we are going to replace that x by log y. So it is a log y.
E raised to power log y. That will be y.
Louder, little louder.
Sir, e raised
E
to
raised to
power
log
log
y.
y.
What is e raised to log y? Directly tell me.
Y.
Why?
Y.
E raised to log
Yes, sir.
y is
Why?
y. Correct.
My voice
So
is
we can
clear.
write it y
Low.
directly. Minus,
Only y.
Minus 2y
okay,
plus log
Plus
y.
log y.
good. So that about upper limit. Okay. Now the lower limit, we are replacing x by 1.
Minus 0.
1 into
Minus.
e raised to 1. It is not 0. E raised to 1 is e itself. This is the minus e or minus in bracket. I will say this is the e only. Again, this is a minus 2e and plus 1. The bracket is kept there for lower limit and the dy will be as it is. So is there any simplification or cancellation? Okay, not bigger simplification. How to integrate the first term now?
Sir, I
By
let.
parts. So
Again by
Again by
parts.
parts.
Okay, again isolate rule. So what will be u?
Excuse me, sir. Sir, e raised to log y है e और log y कट जाएगा, right?
E raised to log y is only y.
हाँ, okay.
So
Sir,
yes.
sir, here we are assuming that the base of log is e. Then only.
No, it is not assuming. Whatever in mathematics the logarithm function comes, this is always a natural log. Only specific if we want the base 10 or other, that should be written then. Okay. All logarithm functions we are considering as a natural log only, base e.
Okay, sir.
Okay, that is not assumption. That is actually always. Okay.
Okay, sir.
So when you say log of x as 1 by x, derivative of log x as 1 by x, that is also of natural log only.
Yes.
Okay.
Thank you, sir.
Yes. Integration now. What should be the u here?
Log y.
Yes,
Log y.
u and v. Again by parts. So first into integration of second
Log y square by 2.
minus
Minus
derivative of
1 by y.
1 by y.
1 by
1
y
by
into y
y.
square by 2. So that is y
हाँ,
by 2. So I will write
y by
y
2,
square
yeah.
by 4 directly. So this is the
हाँ.
direct by parts. You have to do it on the rough if you are not getting this step. Okay. This is a integration by parts applied to this term. Now integration of this term minus 2y. Is it
Y
minus y
square.
square?
Plus y log y minus y.
Yes. Y log y
Sir, y
minus
log y
y.
minus y.
This is a minus e plus 2e, so it is a plus ey, is that?
Yes, yes, sir. It will be plus
minus
minus
EY.
y.
Minus minus
Achha,
plus.
okay, okay.
And last one is a minus y. The limit of y is 1 to e. So that about the integration we finished. The simplification and integration is done in single step there. Now only last step is left. We have to substitute this upper and lower limit and we will get the required answer then. Any doubt, anyone? Okay, 150, you have problem. Yes, got it. Any doubt up to this step? Whatever in the green color I written, that is a by parts. I'm writing this is also the by parts, these two terms. I will erase the first step here so that I can write the remaining two steps there, last one or two steps we left. Now we take here that let me replace upper limit. So I will ask 160, 160.
Yes, sir.
Yes, replace this upper limit e and lower limit. What will happen? Tell me here.
Log e to the base e1, sir, that would be 1.
Yes, very good. So that is one more thing we are going to use it now. Log e is 1.
Yes, sir.
Okay, so if it is
Then
1,
it would be e square by 2
okay, correct.
minus 1.
Minus e
Oh,
square
sir.
by 4.
Okay. Minus e square
Okay,
plus e
correct.
minus e
Good.
plus e square
Okay,
minus e.
okay, good. So this is for upper limit.
Yes,
Minus,
sir.
now lower limit.
Log 1 0. It would be 0.
Yes, log 1 is a 0. Already we know that. So this is 0.
0 minus 1 by 4 minus 1 plus 0 minus 1 plus e minus 1.
That's one. Correct. Very good. So few of the terms gets cancelled here, like plus e minus e gets cancelled, plus e square minus e square gets cancelled, and we get then the required answer. The answer is here.
Sir, if you don't mind, can you solve the last part, please?
Pardon?
Can you solve ahead of this, please, if you don't mind?
Okay, no issue. This last expression, na, this one. What is the difficulty there?
It's no difficulty. I'm just getting 2e square instead of e square. So I don't know.
No, one of the e square already got cancelled, na, here. So this simplification, if you observe, we are taking LCM here. So let by 4.
Minus e square by
So it is a
Minus
plus
e.
e square by 4. Na?
Oh.
Simplification
Got
of
it, sir. Got it, sir.
okay. E square by 4. Now this is a minus e is a minus 2e, and the last is a minus 1 by 4. This is a 4. This minus 2. This minus, no, not minus, minus 3 is there. Minus 1 by 4 minus 3 is a minus minus plus 13 by 4. That's the required answer. This is the answer.
Sir, how many marks question is this?
Pardon?
How many marks question is this?
This is for 5 marks.
Okay.
Not a single question generally have the weightage more than 5 marks. Generally the weightage is given as 5 marks. Yes, in some cases it may possible because 10 marks can be divided as a 7 plus 3 also. So maximum 6 to 7 marks questions will be possible, but majority of the times the questions are asked 5 marks like that.
Okay, sir.
So few of the values we used. So this is the thing you should know of the log values there. Mainly log of 1 is a 0, log of e is a 1, log of e raised to x is x, or e raised to log y is, or e raised to log x is x, that way. Okay, so that are the few properties of logarithm are important. Done?
Yes, sir.
So I will show you the next question then. Third question is on the screen here now. We have to evaluate the triple integration of x plus y plus z. Now you should tell me the order of integration. Is it correct? Dx, dy, dz?
Yes, sir.
Yes, very good.
Yes, sir.
Order of triple integration is correct because inner limits are in yz, but possible order is only one again. So here is no ambiguity at all. Whatever the given, that also have to follow, and even though if you see the limit also decides the same order, because inner limits are in yz, so that should be integrated with x first. So that is the important thing. So let me start integration. -2 to 1, 0 to z, let us 106.
Yes, sir.
Integrate with x.
Sir, x square by 2
Okay,
plus yx
very good.
plus zx.
Okay, one of the simple integration that we have. This -2 to 1, 0 to z as it is. So let me replace upper limit now. So when we replace y plus z as limit of x here, so y plus z bracket square upon 2 plus y into y plus z plus z into y plus z. That about upper limit. Lower limit of the minus sign. So minus y minus z bracket square upon 2 minus y into y minus z minus z into y minus z, and that is a dy dz. dy dz. Now the most important thing, it looks complicated, or some of you may thought this is a very lengthy, it's difficult. Yes, it's a lengthy, it is correct, but it is not difficult. You have to go step by step, you will automatically get the answer. Just focus on the first two terms. If you focus on this first term and this first term, and if you simplify, you will get the first simplified value. -2 to 1, 0 to z. And what is that simplified value for these two?
2zy.
2yz. Very good. Similarly, if you focus on these two terms only, and if you simplify that, what is that term? That is also 2yz, is it? Because
Yes,
y
sir.
square gets cancelled. Sorry, not y square. This is plus y square plus yz minus y square. Yes, y square gets cancelled, correct. And the last thing, that if you similarly simplify these,
2z square.
yes, 2z square, correct. You can do this simplification in the rough also, like which term getting cancelled you have to see, and then you have to write this part. You will observe this is the remaining terms, and now the thing is left, we have to integrate this with y and then with z.
Excuse me, sir.
Yes,
So I think y square will not get cancelled
here
because, yeah, sir.
here is a minus sign, and this
So
is
the
plus.
previous minus that is
Not previous. This is an individual minus sign already given there.
that previous minus is for whole bracket now.
No. It is, you are replacing lower limit of the minus sign. That minus sign given already in the bracket. So here is plus.
Okay, got it, sir.
So y square only gets
Excuse me,
cancelled.
sir.
Yes.
So in exam, if we will do like this, that
Yes, you will
means
get a full marks. Don't worry.
directly.
Yes.
then it's okay or not?
It's okay, no issue.
Okay, sir.
Important part is your logic should be correct. You can drop these simple simplifications, no issue there. Examiner can understand that you've done it in rough there, probably. Okay, so that about the first integral, that outer inner integral. Now we have to integrate with y now. So to integrate with y, so the limits -2 to 1, and okay, I will write it, the integral again here. The 2yz plus 2yz become 4yz plus 2z square, and then dy dz. So these two terms combined, okay, because they are similar, and now we can integrate it. Minus 2 to 1 as it is. What's the integration now?
2y square z
2y
cube.
square z.
Correct. 2y square z plus
2yz square.
2z square y, or okay, that is correct. And limit are 0 to z dz.
Yes, sir.
Now if we put limits here, it becomes 2z cube plus 2z cube, that is a 4z cube dz. I'm written directly, and that is a 4 z raised to 4 by 4 minus 2 to 1. So that 4 gets cancelled, and if you observe, we are taking 1 raised to 4 is 1, minus 2 raised to 4 is a 16, and that is a minus 15 is the answer. The answer is a minus 15. Few of the students make a silly mistakes in the last step, because they may write 2 raised to 4, minus 2 raised to 4 is a minus 16, that plus 16, and they write 17 as answer. So in some cases, there are few students who have the problems in the indices, mainly properties. It's so simple. If you go step by step, one by one integration, looks only complicated, but it's very simple. Any doubt, anyone? Can we move to the next question then?
Yes, sir.
So question number 4. Can anyone tell me the order now? What should be the order of integration?
So first we will
dy.
integrate dy.
dy.
Yes.
Yeah.
dy.
We should integrate now with respect to y, as limits are in x, z. So order should be dy first. Okay. And then z is there. So we left with x and z there. So limits are, inner limits are in z. So that should be then of x and z. So this is the correct order now. Okay. dy dx dz. dy dx dz. So this is the similar example just we
Sir,
finished.
this I could not understand, sir. How dy is first?
Because limits are in xz, na? So when the inner integral have the limits in variable xz, that should be of y only. Are you getting? When limits are in single variable, you have to follow the order as it is. But when it is given in two variable, say xz, then that should be of y.
Okay, sir.
Okay. So suppose you have limit hote x plus y and x minus y, then that will be the limit of z. If limits are in xy, that should be of z, obviously. So this is a solved example in the book. I will show you a solution because it's similar example again. So here is the answer. You'll observe the first integrated with obviously the integration is done with y. So this is the integration integrated with y. Then upper limit and lower limit is replaced for y, and later on the integration is done with x, then with x. So this is the integration of x, treating z a constant, and at the end integrated with z, and we observed the answer is coming as a 0 there. So this is the solved example, is similar to the previous question. The order, if you want to see, let I show you again. Let I come to the previous example here again. You'll observe what are the limits. Limits are in yz, na? Y minus z and y plus z. These are the limit. So this should be of the variable x. So the order is a dx first. So dx is important. So that you should keep in mind. But in the next question, here you will observe the limits are given as x minus z and x plus z. So that should be of the variable y only. So the order should be dy first. So here, even though dx is given first, that's not correct. We should do it dy. Clear? Is it clear? 107.
Yes, sir. Thank you, sir.
Okay. So that about the order, that you have to focus on limits mainly. Limits gives you the order when it is in two variable. Next question is here. Now limits are in single variable, 0 and x, only x. So whenever that is the case, whatever the order given, that you have to follow. You should not think about the order now, because limits are in single variable. If it is x plus y to x minus y, then we can say that is of only z. Only z. But right now we can't say it is of only z. It can be of y also. Because of that, whatever the order given, that you have to follow it. That's one. Do this calculation then. Or can you do it your own?
Yes, sir, we will do it.
Okay, it's a 4 by 35 is the answer there. You'll observe it's a simple example. First integrate with a z, so integration of dz is z only, and this is the limit. You get x into 1 minus x. Then this is y square to 1. Okay, this is the limit is y square to 1. Then you integrate with a x, and at the end you integrate with a y. You should get 4 by 35 as answer there. Last question then. So here is the last question. Our aim is to integrate this 0 to 1, 0 to root of 1 minus x square, 0 to root of 1 minus x square minus y square. So what about the order?
Z.
It is the same as it in the question, sir.
Yes,
It will
correct.
change.
Same
Yes,
as
Z.
written in the question, because limits are in xy. So z should be the first, and that is given also. Okay, both are the same. So let me do this question, the last example, and then we'll stop it. So the integral I.
Sir, what was the answer of the previous question, sir?
4 by 35. So this is the double integral that we have. What is the integration?
X, Y, Z square by 2.
Z square by 2. Limit of z. And that is a dy dx. This is 0 to 1. If we replace a limit, this is x, y, 1 by 2. Z square gives you 1 minus x square minus y square dy dx. Yes, anyone? What should be the next step?
इंटू करेंगे सर सबका फिर मतलब
Sir,
डिस्ट्रीब्यूट
multiply कर
करेंगे.
देंगे.
No. Instead of that, the best way is there. That is one of the way. Yes, you are multiply by x inside and then integrate with y. Okay, you can multiply xy in the bracket and integrate with y. That is
Substitution, sir, substitution.
not substitution also. The best method I am asking.
Sir, we can write that one a minus b whole square.
No.
I take half outside and multiply xy to the bracket.
Yes, half can be outside, that is okay, but the method that for integration, the best method for integration here, whatever you are thinking, yes, 126 given the correct answer. You're saying polar form. We should go to the polar because you'll observe this is the equation of a circle, y equal to root of 1 minus x square, y equal to root of 1 minus x square, that is x square plus y square equal to 1 is a circle. So right now the region of integration, the simplest method is a polar form. If you go in Cartesian, that is also correct. I'm not saying that is wrong. So the equation that we have is, you'll observe it is bounded by y equal to 0. So this is y equal to 0. Then y equal to root of 1 minus x square, root of 1 minus x square, x equal to 0, and then x equal to 1. So this is the x equal to 1 line. So this is the region of integration. The region of integration is the arc of a circle in the first quadrant. So whenever that is the case, it's better we go in a polar form, and the limits will go to r equal to 0 to r is equal to 1. And the double integral will become, now I'm writing it in a polar form. So limit of r is a 0 to 1. Is that? What about theta?
0 to pi by 2.
0 to
0 to
pi.
pi by 2. Value of x is r
0 to
cos
5 by
theta. Value of y, r sin theta.
r sin
And that 1 by 2 is as it is. This 1 minus r square r
r
dr
square
d theta. So that about a
r dx
transformation
dy
to the polar.
dr dy.
And now this calculation is definitely a simple than the Cartesian form. And you will get the answer, which is 1 by 48. So whenever you have to do some task, many of the cases you have the multiple ways. Now choice is yours whether you have to go by a simple path or you have to select the difficult path. Right now the simplest path is a polar form. If you go in a Cartesian form, that is also correct, but it is a difficult
So,
path.
sir, in limit, how you took
Limit,
Can
one?
you please explain it again from step 2?
I'm not getting.
Hello. Sir, please explain from step 2.
This is the step 2, and you will observe what is this is the limits of y, na? So what are the boundaries? Y equal to 0, y equal to root of 1 minus x square, x0, x1. So we've drawn that curve here. And as the boundary of the region of integration is a part of a circle, we transform in polar. What are the polar transformation for circle region? That is x is r cos theta, y is r sin theta, dx dy is r dr d theta. That's the use of a transformation for simplify the problem.
Sir, in this, the limit is 1. How did we come to get this?
Little louder.
Sir, in this limit is 1, 0 to 1. Then
So,
how we got it?
so this is the
In the
limit.
last step, last step.
This is the limit 0 to 1 is of x, na? So x equal to
Yes.
0. X equal to 0 is y axis. This is x equal to 0. What is x equal to 1? X equal to 1 is here. Then y equal to 0. And this is y equal to root of 1 minus x square. That's the region. You should draw na. Abhi.
In the third step, I'm asking, sir.
Pardon?
In the third, in the polar coordinate.
Are, when you take a radial strip, where the region start, r equal to 0, where it touches circle of radius 1 is x square plus y square equal to 1 है ना circle का equation.
Yes, sir.
This is already we learned in polar. So if you are not getting, that means you are still lagging there. Okay. Those who are not getting this step now, they are still not prepared anything in polar form. Then they require practice then. So that integral I will write it here, which is a 0 to pi by 2, 0 to 1, that I collect the terms of r, 1, 2, 3, it is r cube. So 1 by 2 is a constant as it is. This is 1, 2, 3, that r cube we have to multiply in the bracket, so it will become r cube minus r raised to 5 and sine theta cos theta d theta. That about a simplified step. Just we collected that terms together. Now the integration with dr d theta, my mistake. So dr d theta. Let me integrate with r and with theta simultaneously, because it is function of r into function of theta form. Whenever it is in function of r into function of theta and the limits are constant, you can do that. So 1 by 2 as it is. What's the integration of r cube?
So I didn't understand the step you did right now. R cube minus R5, R raised to 5.
You can see here, this is simple simplification. How many r's are there? 1, 2, 3. Multiply these 3r in this bracket. Are you getting?
Yes, sir. Thank
That's
you.
one. So you should think on the problem, na? The simple simplification. You should see there what we are doing. Okay. So tell me integration of r cube. Lecture मध्ये आता. This is r raised to 4 by 4. Then r raised to 6 by 6. Limits 0 to 1. What about the 0 to pi by 2 sine theta cos theta?
So we'll convert it in sin 2 theta.
Yes, we multiply 1 by 2. So there is 1 by 2, and the integration of sine 2 theta is a minus cos 2 theta upon 2. It's a 0 to pi by 2. That's one. This is a 1 by 2 sine 2 theta. So 1 by 2 is here, because multiplied and divided by 2. Sine 2 theta integration is minus cos 2 theta upon 2. And the last step is now just put upper and lower limit. You should get this as answer 1 by 48.
Sir, but the last integration would be in terms of theta only, ना? तो हमने r को r by 4 r के पावर 4 by 4 किया है. R का तो या तो it's either you use both the integration in just one step, or क्योंकि अभी इस step में we did r का integration by r4.
We can integrate at the same time. The reason is the limits are constant. When you integrate with r doesn't depends on theta. R की limits 0 to 1 है. If the limits of r is like 0 to 1 plus cos theta, that time you have to integrate only with r first and then with the theta. Okay. So when limits are constant and integral is in the form of multiplication, you can do it. Or if you are still have the problem, integrate first with r and then do with the theta, you get the same answer. Okay. The best way, yes, you do it one by one. The best way, if you have the confusion, always you do it one by one. First integrate only r, then integrate with theta. Okay. Any doubt? So the final answer is 1 by.
You can take sine theta as t, sir.
Sine
Sir, we can take sine theta as
yes, you
t.
can. Sine theta as a t, cos theta, d theta as a dt. That is also the same answer. But okay, that is another way. Good. Substitution also work for